There is a file called stack already. I'm going to use this and add a new worksheet. And the stack as well. Every element has two cells, so-called. In one is data, in the other cell there is a link to the next element. If we have three elements, like those there, and Max and Michelle, Eva-Linda links to Max, and Max links to Michelle, and Michelle links to Eva-Linda. This is next, and this is data in this case. And this is index. We can also display it another way, so that we have here two cells, and here and here. So here is start. Here is something for stack already. Value and position. This is the algorithm for inserting into an existing linked list. And here's the algorithm: insert, value, position as inputs. Temporary, we create the temporary variable. We assign, we create a new node. We set temporary data to be the value, the new value, in our case Tavi. Then next is position, next is temporary. We could make that algorithm more readable, so node at position to insert. Yes. Delete. So what input data we need? Listen. Because here next is Eva-Linda and the next of the next is Max. And now we have a new linked list with Eva-Linda removed. Also we still see Eva-Linda here, but no other node in this list links to Eva-Linda. Start links to Christopher, and Christopher links to Max. Max links to Tavi, Tavi links to Michelle, Michelle links to Jan, Jan links to Henry. As the result, we could just remove this line here. So what if we want to remove Christopher now? That means Here we should put the value max. So here comes max, and now Christopher is removed. And we can remove this line as well. What if we want to remove Jan as well? What is the note at the position to delete? Here we should put end, and now Jan is gone. And we have only Max, Davi and Michelle in the list. So what could be an algorithm for printing out the data inside a linked list? Which construct should we use here? How can we walk through the list? Then we set start to be the linked list. And it looks like this. Reviews, right now, next. Because we can implement linked lists with help of a stack as well. First we initialize stack, and for stack, first we initialize a stack. It has no nodes inside it, nothing in that stack, so the topmost layer is nothing. Next we test whether that stack is empty. Is empty. We just return whether topmost layer is null. Here topmost layer is null, we have nothing in, so if there is nothing in, then it is empty. If there is at least one layer, it is not empty. And next we add an element into a stack new layer. Push value. We need a temporary node for that. So here we also need to set t to be a global, because otherwise we could not access the topmost layer. Here we are inside a block, so we only see what's inside here. Unless topmost layer is declared outside of this block, we could not check for topmost layer for being null or not. Here we create a new node, we set its data to be the new value, and its next pointer is to that topmost layer, which is null. And then we say that topmost layer is the current temporary node. Value is yarn, which is this one here. Then temporary is new node, temporary has data and next, and temporary data and next, temporary data is value, that means yarn, and temporary next is topmost layer. So topmost layer was nothing, so here the value for next will be nothing, and then we say the topmost layer is temporary here. Topmost layer on temporary. That temporary means that it actually has those properties here. And now we have data and next. And next points to nothing here. Okay, let's add more people into that stack. Who wants to be the next one in the stack? On top of Jan. Let's add Michael, so value is Michael this time. And temporary data is Michael. Temporary next is nothing. And topmost layer, we just copy this here. So the result will be that here is Michael. But we still need to update the next or the previous one. Now temp next is the topmost layer was Jan. Temporary. That means the whole this thing here. And next, Ravi. Temporary data is Ravi. Temporary next is the whole topmost layer. And topmost layer is temporary. And now we have the complete structure. So the topmost human is Tavi. Below Tavi the next level, which is actually the previous, because it seems to be more logical for me, is Michael, and underneath Michael is Jan, and underneath Jan is nothing. And now we have a stack, and at the same time this is a linked list. So every node points to a next node here, and this is unidirectional now. Next we want to remove an element from the stack. It is called pop, and from the stack we can only remove the topmost element because we cannot access the elements beneath it before we remove the above layers. So topmost layer is topmost layer next. Let's see whether it works. Inserting, popping. Topmost layer. Here the next is this one. Oh, it works well. Now David is gone and only Michael and Jan are in here. This file is here, computer science data structures. Stack, I rename it data. Oh, I remove this as well. Data structures. And here inserting and popping. Next one, we want to know what is the topmost element in the stack. Get topmost layer. Every time we want to get something, the function must return something. Topmost layer data. Actually, get topmost layer is not very correct. Should be get data of topmost layer, because otherwise we could just return topmost layer, not topmost layer dot data. So getting the data of the topmost layer. And it returns topmost layer data. Topmost layer is here, data value is Michael. This is also correct. And if you want, you can also implement a queue as a linked list. Let's see whether we have some exercises for that. I will write suppose the start is a reference to the first node in a linked list, the very first node, beginning. What is the value of start after we loop? We always assign start dot next to start, so the pointer to the next node, until start becomes this one here. Oh, I think the next one is pretty much doable. Do you know what is non-decreasing? What is increasing, what is decreasing, what is non-increasing, what is non-decreasing? So I just write here some names. Here. Eva-Linda, please fill in the column B, increasing for this list, and Michael, you fill in the column C, decreasing for this list. So that you sort the names increasingly and decreasingly. No, they are not sorted. Now the first name is in place, which is correct.
Are you copying me?
Who can be the last one? Oh, there is no such name. Eva-Linda, can you find the last name? I don't know it is. Okay, it was just gray for me. I couldn't see it. We have now two lists, increasing and decreasing list. The next, non-increasing Now you know what is non-decreasing order. You should write an algorithm to merge two linked lists. You assume that the data in each list are in non-decreasing order. So like here, they can repeat, they can increase, but they cannot decrease. The result is one linked list containing all of the data in non-decreasing order, so in the same order. And you may modify only the next fields of the nodes. So here are two examples, one non-decreasing list and another non-decreasing list, and the result were elements from both lists in non-decreasing order. If you have some worries about syllabus or something, mention those problems in your diary. This way I get feedback and I can enter into a conversation and get some feedback. Or if she will have a conversation, then every Tuesday from now until 20 past 2 p.m. I'm here available. But unfortunately this is the only time. Yeah.